Hi guys and welcome to this new video. Now it's time to study the hypergeometric distribution. The hypergeometric distribution is another discrete probability distribution. It is quite different from the binomial and the multinomial distribution because if you remember, in those distributions the probability was always a constant, and it was always a constant because we replaced the elements that we studied, the element that we observed. And how do we know that? Because the number of elements in the first in the first trial we have n elements, and we have the same number of elements in the second trial, and so on and so forth until the umpteenth trial. So the number of elements never changed. That allowed us to have completely independent trials. However, you might be wondering, what if we do not replace those elements? If we do not replace those elements, the probability changes, the probability of each event changes, and the binomial and multinomial distributions won't work to model those situations. So in these cases we have to come up with a different method to calculate those probabilities, and we have for that case the hypergeometric distribution. So okay, let's explain how to make the experiment. Basically we have a set n, capitalized N, and that set contains two subsets which are K, labeled as success, and capitalized N minus X, labeled as failures. So in that set N we have two subsets, K and capitalized N minus K. And how do we make this experiment? Basically, from the set capitalized N, we are going to take a sample of n elements, and we would like to calculate the probability to get x elements from the subset K and n minus x elements from the subset capitalized N minus X within these n elements, this sample of n elements that we take from the set n capitalized N. So how do we calculate that probability? Very simple. The first term is K choose X. So as I mentioned, from the subset K we are going to choose X elements. The second term is capitalized N minus X choose N minus X. As I mentioned, from the subset capitalized N minus K we are going to select N minus X elements. And the last expression is N choose N, which is the number of ways that I can select n elements from the subset, from the set N. So I know that maybe this is a little bit complicated if we explain it with letters. However, let's explain it with an example, so you will see that it's pretty easy. So now we have a box that contains 10 objects, 3 of which are imperfect. If 4 objects are randomly selected, what's the probability to get that 2 of them are perfect? So if we analyze this example, we notice that we have 10 objects, right? This is our set, capitalize N, and we have two subsets, because we know that 3 of those 10 objects are imperfect. So this is our K, and what's our capitalized N minus K? Is 10 minus 3, which is 7. So we have the success K equals 3 and N minus K equals 7, and we are going to take a sample of 4 elements, and we are interested in knowing what's the probability to get 2 imperfect elements and 2 perfect elements. So okay, now let's just select the formula to replace the values. First of all, the notation. We have H, and what's X? As I mentioned, X is 2. N, capitalized N, as I mentioned, is 10. N is 4 with because it is our sample. And what's K? K is the number of imperfect objects, which is 3. So now let's replace just the values. K choose X. Our K is 3, choose 2, which is our X. And now N, capitalize N minus X, is 10 minus 3, right? N minus X is, is 4 minus 2. So we have 10, we have 7, choose 2. And we are going to divide all that by the number of ways in which I can select 4 objects from 10 elements. So basically it's 10 choose 4. And if we replace this notation by the factorials, we have all this expression. This is basically like the number, like as I said, the number of ways that I can select 2 elements from a set of 3 elements, 2 elements from a set of 7 objects, and 4 elements from a set of 10 objects. If we calculate all those factorials, we get that 3 choose 2 is 3. We also get that 7 choose 2 is 21, and we also get that 10 choose 4 is 210. And if we multiply and divide all those values, we get that the probability of this specific case is 0.3. Well, basically that's the probability to get 2 imperfect objects if we take a sample of 4 objects from a set of 10 elements that contains 3 imperfect elements. We also can calculate the variance and the mean from the hypergeometric distribution, and basically we can calculate that using the following formulas. The mean is n, which is our sample, times k, which is the number of successes, the subset of successes, and we divide all that by m. And the variance is, well, this expression here. We just have to identify what what's capitalized N and K, and we can calculate those we can calculate the mean and the variance. I do not make examples of that because we just have to replace the values, so I do not see like the point of doing it. However, this is all about the hypergeometric distribution. In the next video, we're going to talk about how we can make the hypergeometric the relation between the hypergeometric distribution and the binomial distributions, because even though the binomial distribution because even though the probability is always constant in the binomial distribution and it varies in the hypergeometric distributions, they are related in some way, and it is important to study that. So we will do it in the next video. So well, I hope that you have enjoyed these videos. If you have any questions, please leave them in the comment below, and I will try to answer them all. And we'll just have a great day. Bye bye.